Hello, welcome to my channel. This is Obro and we are meeting after a long days, and so we are going to start with the topic with the three-phase induction motor. So here we can see it is a diagram of the three-phase induction motor is a ring, and it is the copper bar in the iron rotor, and this is the stator part and this is the rotor part where the three-phase supply is given, where it revolves. The rotor part remains rotation, and whereas the stator part details in the stationary mode. So we are going to follow some of the numerical part. So now we are going to erase this diagram and start with some of the numericals. So now the question is a three-phase induction motor. A three-phase induction motor has a four-pole. Three-phase induction motor has a four-pole star-connected stator winding and runs on a 220 volt 50 hertz supply, and other is given the rotor resistance. The rotor resistance is 0.1 ohm per phase, and standstill reactance is 0.9 ohm per phase. The ratio of stator to rotor turns, the ratio of stator to rotor turns is 1.75. The full load slip is 5%. The full load slip is 5%. So what we have to find number A, that is full load rotor impedance per phase, and B is rotor current per phase. Option C is rotor input, and option D is speed at maximum torque. So this is the question. We can see here that the three-phase induction motor has a four-pole star-connected stator winding and runs on a 220 volt 50 hertz supply. The rotor resistance is 0.1 ohm per phase, and the standstill reactance is 0.9 per phase. The ratio of stator to rotor turns is 1.75, and the full load slip is 5%. So we have to find these four terms. So it is very important questions for those who are studying electrical bachelor degree or even the master degree in energy or electrical. So this is a very important questions. So I will go to solve one by one. So first we have to solve that rotor impedance per phase. So I'll mark as a rotor impedance per phase, rotor impedance per phase. So what is the rotor impedance per phase? That is it equal to Z2 is equal to R2 plus JX2. So this is the rotor impedance per phase, is the Z2 is equal to R2 plus JX2 R2, and this will be divided by slip. Yes. So we have to find, first of all we have to take the given data. What are the given data here? Given data, that is voltage is equal to 220 volt, frequency is 50 hertz, reactance, standstill reactance, that is 0.9 ohm per phase, and 0.9 ohm per phase. This is the and the rotor resistance. This is the rotor resistance, that is 0.1 ohm per phase. So these are the given data, and other is full load slip. Slip is given as 5%. So we can write as 0.05. So we can understand the data. This is the given data. This is the frequency, voltage, slip, resistance and reactance. So we can put here the data, what are the given here, the rotor impedance per phase. So we can find out here what is the reactance. Resistance is 0.1. So we can write here 0.1 divided by slip is 0.05, and here we can write here reactance is J, X2 is 0.9. So we just put the following data, and if we can solve here, that is it is just nothing but 2 plus J09. So we need a scientific calculator to calculate 2 plus J09. If we have a scientific calculator, we can get for value 2.19 ohm. So this is equal to Z2. So what are the other things we need to find out? So we have already got the first action, 2.19 ohm. That is the full load rotor impedance per phase. Now we have to find out the rotor current per phase. So we have, it is option B. So what is the rotor stator voltage per phase? That is a stator voltage per phase. Stator voltage per phase, that is nothing but we can get the value from here, that is E1 is equal to 220 divided by root 3, because this is the 3-phase voltage. So it is already given 3-phase voltage, 3-phase induction motor. So we are just dividing 220 divided by root 3. So 220 divided by 1.732. So if we just calculate this one, we will get the value as 127 volt. 127 volt. So this is the stator voltage per phase. So other we have to find, that is the rotor voltage per phase. So rotor voltage per phase. So the rotor voltage per phase. Rotor voltage per phase is nothing but is given as E2 divided by, so we have found this one, that is the E1 value is 127. So we'll just write the value 127 divided by 175. So if we just calculate this one, we will get as value 72.6 volt. So I hope you have understood how we have got this value 1.75. That is because of the ratio of the stator to rotor turns is 1.75. So just we have divided E1 divided by rotor to stator turns, that is 1.75, will get as 72.6 volt. This is the answer. So what are the other thing we have to find? That is the rotor current per phase. So other is rotor current per phase. So rotor current per phase, that is nothing but I2 is equal to E2 by Z2. So what is the E2? E2 already we have found the value 72.6. So we'll put here 72.6 divided by Z2. Z2 is nothing but 2.19. So if we just divide these two values, then we will get as values as 33.14 ampere. 33.14 ampere. So I hope you have understood how we have calculated this rotor impedance per phase and the stator voltage per phase, rotor voltage per phase and the rotor current per phase. So we have used E1, this is E2 and this is I2. I2 is equal to E2 by Z2, and so we have got the value as 33.14 ampere. So we will solve the other part of the question. I have to just erase this part. So other part is given as here, that is the rotor input. Option C is rotor input. Rotor input is nothing but rotor copper loss divided by slip. So our rotor input is rotor copper loss divided by slip. So what is the value of the rotor copper loss is already given, we have found out, that is 300